Welcome back, everyone. So example 7 will be starting in a moment. Again, example 7 and 8 are pretty much the same thing as example 5 and 6. So if you'd like to try these two on your own, I say go for it. Otherwise, follow along with Miss Long. Okay, so in example 7, unfortunately, example 7, you can't do any of it on your graphing calculator. So unfortunately, you can't do it on there, but you can do it on Desmos.com. And I'll explain why again. I'll try not to forget this time. Okay, so let's go ahead and graph this on Desmos.com. And I'll try to actually graph the correct function this time. Okay, so we're going to have y equals. Again, for the square root, you can type SQRT. RT. Or you can click the square root button on the keyboard feature. It's up to you. Alright, so we have the square root of 2x minus 1. Alright, and that's it. Alright, so first of all, we want to find the x and y-intercept, which if you see here, holy hot dog, we already know the x-intercept. It's at 0.50. Okay, this one does not ever cross the y-axis, which means it doesn't have a y-intercept. Now, the reason why you can't find anything on your calculator on this one is because on your calculator, which I can show you why it doesn't work. I'll just show you so you kind of understand why it doesn't work, if I can turn it on. Okay, so I go to y equals. I'm going to hit second x squared to get my square root button, and then I'm going to type 2x minus 1. And remember, since we're subtracting here, we use the subtraction button, not the negative button. You only use the negative button if the number out in front is negative. Okay? Alright. And then I'm going to hit zoom 6 to get a 10 by 10. Which again, looking here, it doesn't even look like it's hitting the x-axis. So again, your graphing calculator can be a little bit misleading. I'm going to hit zoom in, which is 2. So I'm going to hit zoom, then I'm going to hit 2. Alright, I want to zoom in right around the start point, because right now it doesn't even look like it has an x-intercept. So I'm going to hit enter. I'm going to get my little cursor guy right around the start point. Alright, which if you see, it still doesn't even look like it's touching the x-axis. And the reason why, you guys, is because your calculator, the pixels on it are only so large, so sometimes things won't show up, which let me make sure I typed that in right. Yeah, I typed it in right. So if you see, your graphing calculator kind of limits you. I could try zooming in again. So I'm going to hit zoom, and then I'm going to hit 2 for zoom in. Okay, again, you guys, if you see, it doesn't even look like it's touching the x-axis. Okay, but if I try to find the 0, because I know there's a 0 at 0.50, even though my calculator is kind of lying to me. Another way you can find it, you can look at the table. You could hit second table, and when x is 0, or I'm sorry, this is where y would be 0. So let's see here. See, it's not showing up on here because our y value is a half. So again, it's kind of tricky, or the x value is a half, and I currently just have whole numbers. There's a way to change it. If you hit, I'm pretty sure if you hit, let's see here, table set, if you hit second window, if you hit, let's see here, I think this button right here, if you change it to 0.5, and then if you hit the second graph button, it'll pull up your table. Now it's in 0.5 increments. So you can see at 0.5, there is a 0. But if you're just looking at your graph, well, it doesn't look like it. But if I try to find it using the second trace button, I want to find a 0, so I hit 2. Okay, it says left bound, which currently I don't even have a point on the graph. I'm going to hit my right button until I actually get on the graph. So let's see. It's going to take a little bit. Okay. So I need to be to the left of the 0. Currently my cursor is to the right of the 0. So if I try to go to the left, okay, if you guys see, I'm not even on the graph. If I hit enter, and then if I scroll the other way, now I'm to the right of the 0 and hit enter. See, it doesn't really let me calculate it because I had to go off of the graph to scroll to the left. So if you see, sometimes your graphing calculator limits you on a square root graph. Okay, but Desmos.com won't. So if you see, we know our 0 is at 0.50. Okay, so going back here, I know my x-intercept is at 0.50. So this right here is my x-intercept. All right, my x-intercept is at 0.50, or where x is equal to 0.5. You can write it either way. All right, and then this one doesn't have a y-intercept, so I'm going to write none. And we're sad because we don't have a y-intercept. All right, now remember, to identify the maximum or minimum, we're going to go to the start point, which is right here, which happens to be the x-intercept. Okay, and then that point is either the minimum or maximum. So what do you guys think? Is this point the absolute highest or absolute lowest your graph will go? Well, this is the absolute lowest point on the whole graph. It's the lowest that your graph will ever go. So this is going to be a minimum. So the minimum is going to be at 0.50. All right, and then this one doesn't have a maximum because the graph is going to keep heading upward for forever. So it doesn't have a maximum point. So we're going to put none for that with a sad face because it doesn't have one. All right, then the end behavior, again, you want to know where is your y value headed on the left and the right side of the graph. So as we're headed to negative infinity on the x, which means as we're headed to the left, what y value is the graph approaching? Well, the y value that we're approaching is the y value in our start point, which happens to be 0. Okay, and then, so this is as we head to the right. As we head to the left on the graph, so as we head to positive infinity or to the left, or sorry, good golly, Miss Long, mixing up my lefts and right. As we head to the right on the graph, sorry guys, so this is left, this is right. Alright, so as we head to the right on the graph is going to continuously head upward. So we're headed to infinity and beyond with Buzz Lightyear. We're heading up for forever. So we're headed in a positive infinity direction, which means we're heading up. Okay? Now your interval of increase or decrease, as we head from left to right, we are heading upward, which means the graph is increasing. And remember the shortcut, it's going to be x is greater than the x in your start point, which is the 0.5. So this would be x, for my interval of increase, x is greater than 0.5. Okay, the interval of decrease, we don't have one, so it'd be none. And again, you guys, you can always check yourself if you type that inequality on Desmos.com. So if I type x is greater than 0.5, look at that. It shaded the entire graph. So again, if you don't really know what to write for your interval of increase or decrease, whether it's a greater than or less than, you can always check yourself on the graph. All right, and the last thing we need to find is the domain and range. Okay, so again, the domain, there's two ways you can do it. You can either set everything inside the square root to be greater than or equal to 0. So I could say 2x minus 1 is greater than or equal to 0, and I could solve. So I'm going to bring negative 1 to the other side. I'm going to add that bad boy on both sides. Negative 1 plus 1 will cancel and turn to 0. 0 plus 1 is 1. Alright, then I have 2x is greater than or equal to 1. Okay, and then I could divide, since the 2 and the x are secretly multiplying, the way that you move 2 over is by dividing it on both sides. Okay, which the 2's will cancel and turn to 1. So we have x is greater than or equal to 1/2, which is the same as 0.5. Okay, so that's one way you can find the domain, or you can simply ask yourself, how far left and right does your graph go? Which the furthest left it will go is to this 0.5 in our start point, and then it heads to the right for forever. And these numbers are larger than 0.5, so it'd be greater than or equal to 1/2 or 0.5. Okay, and then the range, again, you can either use the graph or do the shortcut. So the graph, you can say, how low does the graph go? Which the lowest y value on the graph is 0, and then every y value above it, as we head upward, because the graph heads up for forever, is larger than 0. So you could say y is greater than or equal to 0, because these values are all larger than 0. Or the shortcut, since we're increasing, we know it's greater than. And then it's greater than or equal to the k value if we're thinking about transformations, which this one doesn't have a k value. So if you don't have a k value, that means there's secretly a plus 0 on the end. Because if you add 0 to anything, you get the original number. So the k value is 0 in this function because we don't have one. So you could still say y is greater than or equal to k, which happens to be 0. Well, there you go, you guys. The final thing, we need to name our graph because every graph deserves a name. This graph's name will be, it will be Claire. Well, there you go, you guys. That's it.